Okay. Announcements. And if your classmate shows up, I'll just have to repeat them then. So I need to make sure that you know this much. So today, the current homework is due, except not all of it is going to be due, because unless you worked on it and solved it independently, I didn't, okay, in the other class, I just was not able to get to the number 21 on the last page. Just didn't have the time, wasn't able to explain to them how that kind of problem would work. I only just finished explaining 19 and 20 before the period ended. But I still want 1 through 20 so that I can grade those over the weekend and have them for the students, because next week, we don't need, I'm not having class here because it's honors day, so on principle, I think that's a rule. That means the next class period is next Friday. My plan is give back graded assignment on Friday so that we can review and talk about things, work more examples, and then hate to keep moving things around. That puts the scheduled test date on the 26th or the 28th. I hate to keep moving it, but I also hate to not have a review day and not give you back an assignment that you can use to study. So that's the scheduled date. However, I fully understand that everyone is trying to cram testing that particular week, and I don't want, if someone has an option that can make their life better for them, and I don't want to force them into taking an inconvenient time for them. So this will be the scheduled test date, but if you or anyone else you know has a conflict because there's just a million tests that week or even that day, we can work something out and you can find a different time to take it. I've got at least one student who's probably going to take it after class on Friday. So there are options, that's just the scheduled day. So today, by the end, we will have worked together everything through 19 and 20, and I'm literally just thinking, rip the last page off, hang on to that one for a little while longer, we'll keep working on it, and all I need from you today is your answers and work from 1 through 20. We're going to do 19 and 20 here together, and that'll just be passed in as the main homework 7 for right now. In addition to that, I have homework 6 graded, and I do want to go ahead and give out one kind of additional assignment. It says homework 8, and it kind of is, but it's very different to the others, and it will not be due anytime soon. Like, I might take it up the last day of class, maybe. That is just something I want people to be working on, so that they can be thinking about putting some work into Newton's laws as a passive background activity. So it will be due, just not before the test.
We finished it, and you want us to
I mean, I'll take it whenever you're done with it. If you finish and you don't want it on your person because you'll forget about it, I'll take it then. Because I know I've handed things in early because I would forget to turn them in. If I finished it early, I would forget to hand it in later. Frankly, my brain does that sometimes. Okay. Problems 1 through 20 due today. Homework back and review day next Friday. Assigned test day the Wednesday after that. And then we will meet Friday the 30th and Wednesday May 5th as our last days of class to review and tie everything together. Questions, comments, concerns, etc.? Okay. I feel like I've been running around like my head chopped off recently. I've been having to change a bunch of things across all my classes because either things coming up I couldn't have foreseen, or I feel like I might have just missed things. that are leading to all these crazy changes. I originally said we were going to take the test a month ago, so I apologize for crazy changing and randomness and trying to make it so that it's better for the students, but I've ended up changing it like, what, 4 times now?
Quick question. You don't want to test them, you don't have to test them, not have to test them before they test them.
Normally, yes. Depending on quarantine rules in the fall, are you taking it in the fall? Okay. I'm teaching it in the fall, and normally, yes, the formatting would match up pretty spot on. However, because those classes tend to be bigger, I've been giving the tests over a online platform so that not everyone has to all come together in the same place as much as to avoid that where possible and to give people a little more flexibility on when they take it. So depending on quarantine rules, that might affect it, but to get to the heart of the question, yes. Under normal circumstances, yes. Okay. So, let's talk about falling projectile motion and how to do 19 and 20. So, I believe we've already talked a little bit about gravity and free fall. I think we've talked about most of these things. An additional point though, this formula that I briefly mentioned, force equals mass times acceleration, that is, by definition, Newton's second law. So, at least for that, the homework 8 assignment, that's one of the answers already. So, when something is actively falling, it's only accelerating in the y-axis at this rate, that automatically means its x acceleration is just going to be 0. So, whenever you're falling in free fall, when you are a projectile, even if the question doesn't tell you these numbers, you can assume these two numbers all the time. And that's going to be what we do in 19 and 20. I believe we already looked at this image. And same thing here. So, and 20 are both very similar. We're just going to change one thing between the two of them. So, the physical situation, we are going to be standing on the edge of a 30-meter tall cliff, and we are going to throw a rock straight horizontally away from ourselves. And I try to divide the questions up into pieces, just to help parse through how they should be done. First thing, draw a picture of what's happening. We have our cliff, we have a rock being thrown off of our cliff, and the initial velocity number isn't actually set until part B, I apologize. That initial velocity will be 10 meters per second in the x-axis. We are only throwing in the horizontal direction right now. So, part A, we draw this picture, we show the velocity vector. Part B, sketch that vector and find the x and y components. What's the y component of this vector going to be? 0. We're going horizontally, we are throwing entirely horizontally. Its initial y velocity will be 0. Meanwhile, its initial x velocity is the full 10 meters per second. So, starting to list variables now. We don't know how long this rock is in the air for. We don't have time. We also don't know how far away from where we throw it it's going to land. We do have a pretty good idea of its trajectory as it's going to get there, though. We've seen things falling, they form along this arc shape, because as they fall down, they continue to move forward. Since the A acceleration is 0, its x velocity can't change. It will remain constant the entire time. So it will continue drifting forward at constant velocity as it accelerates towards the ground. A combination of both together at once create this part of a parabola. Now, part C, the y component is as if the stone is simply dropped from the 30-meter high cliff. How much time does it take to hit the ground? As long as your initial y velocity is 0, any two objects dropped from the same height will take the same amount of time to hit the ground. I think Newton did an experiment where he dropped like an egg and the equivalent of a bowling ball off of a building. They both hit the ground at the same time. They're both accelerating at the same rate. So in ideal circumstances, only the physical y height determines hang time. Hang time just being time in the air. And so to figure out hang time, we're going to want to, for any type of question like this, and these types of questions are called projectile motion questions, because we're throwing a projectile and we are tracking its motion. For all these types of questions, after you draw your picture and sort out what variables you have and the ones you want, the two steps, the two things we will eventually need to be doing, the order might flip-flop occasionally based on how it's asked, but the two things you're always going to need to do is examine the y-axis, which will determine the hang time, and the x-axis, which is completely separate from the y-axis, except for hang time. Time isn't a vector, so when you find time, it's going to be the same time in both axes, because the time you spend falling is the same time you spend going forwards. And eventually you'll hit the ground and the time will be over. So the typical order of operations is always start with y, find time. Sorry, it's typically start with y, find time, use that time to find range. So, that might be inverted occasionally. Sometimes you might be told range and you have to work backwards to find like your launch velocity. But moving forwards, finding range, that is your standard procedure. And these, the equation number 3 is the one that you're going to want to be using because, at least vertically, we are accelerating as time passes, as we move some distance down. So we need to take that into account, and this is the formula we like for that. So in that y-axis, using only y-axis variables, our delta y, our displacement in the y-axis, is going to be negative 30 because we fall 30 meters beneath where we started. to our initial y velocity times time. That initial is 0, so this whole term will just go away. Then plus 1/2 times a, which is negative 9.8, times t squared. Wonderful. So that is the time we spend in the air. And because it's going to be the same time across the entire question, doesn't matter x or y axis, we can now use that in the x axis. So horizontally speaking, for part D, we want to figure out the distance we travel horizontally. So leaving this as our unknown, our Vix is 10 meters per second. Our time is 2.47. Plus 1/2 times our acceleration of a whopping 0 means that whole term just goes away. Nice. It would be meters, yes. So that's approaching 100 feet. That would be the answer to D. That is how far from the base of the cliff the rock lands. We call that the range. Yes. Sorry, say again?
It says the both the x and the y components.
Oh, did you say B? Oh, I'm sorry, my ears don't work so good. I thought you were asking about D.
Oh.
This is the answer to D. The answer to C is this time, and B, sketch the vector and find both the x and y components. There is no y component of that velocity vector.
So you did the whole thing,
Yes. Sorry, 19, the initial paragraph of 19 is the whole question. A, B, C, and D is like the piecemeal steps of getting to those two answers. How's that one feel? Okay. This is probably the most common type of projectile motion question you're going to get in Physics 1500. There are some variations of it, and there are a couple of ways that it will appear that will make it a little bit trickier. And that's what number 20 is going to be. So I'm going to reuse some of the same stuff. When I erase something, that doesn't mean you need to erase anything. But looking at 20, first of all, there's a typo in 20 because the initial paragraph says how fast we launch the rock, 10 meters per second at 30 degrees, and then part B goes and contradicts that. So it is okay to manually change that back to a 10. We're going to stay at 10 meters per second because let's just say that it's the same person throwing at the same speed, they've just changed their launch angle now. And we're going to see what effect that has. So, now, same initial launch velocity, but pointing in a slightly different direction. We've changed our launch angle. We're going to see what effect that has on the range. We're going to go through the same major steps with a couple small variations contained within. We have our new setup, same cliff, same rock, same pitcher, but now the angle is different. Going through the same steps, draw a picture, you have this, be sure to draw the initial velocity vector. It is now on an angle. What are the components of that vector? Because in order to look at each axis separately, we first need to separate the components of that one vector. These two things are still true. In the situation where you throw something upwards, as long as you threw it and it's not flying or it doesn't have a parachute, it is still technically falling. The entire time, it is only under the effect of gravity. Once it leaves my hand, it enters the falling state, even if I threw it and it starts by flying upwards. Because you can be moving upwards, but you can still be in the state of falling. Because the acceleration is just the change in velocity, your initial upward velocity means you start going in this direction until eventually gravity reduces your speed and then starts pulling you in the negative direction. So this entire time, even though it does go up part of the time, these two numbers are still true.
Acceleration
They would, yes, because now that we're at this new launch angle, I suppose I should do it like this. Now that we're at this new launch angle, we not only have some forward velocity, we also have some upward velocity as well. So this isn't going to be zero anymore, and VIX will also probably be smaller. Even though we pitched it at the same speed, not all of that speed is in the x-axis anymore. So we must employ some trig. Sine of 30 is opposite over. So that means our initial y velocity should be about 5 meters per second upwards. And cosine of 30 equals x over 10. So x is 8.66 meters per second. X-axis. Rather different initial velocities this time. questions so far? Okay, so we'll proceed from here and see how much that how that changes things moving forward. We're going to go through the same steps looking at the y to determine hang time and then plugging that into the x. But looking at the y-axis, our delta y from start to finish is still going to be that negative 30 because from the beginning to the end, we still end up 30 meters beneath where we started. Even if we went up for a little bit, we're not looking at an endpoint up here, we're looking at an endpoint there. So that delta y is still going to be negative 30. What is different is our VIY, that's not 0 anymore. But our acceleration is the same, so that piece is unchanged. However, this particular situation has introduced a new problem. It starts with a Q. Yep, we have a quadratic. So I don't want to bog us down too much with that, so I'm just going to get it into the quadratic form real quick. Our A term is negative 4.9, that's important. Our B term is positive 5, and our C term is positive 30. So we move the negative 30 over, that'll be positive. So those are the three things that we would pop into our quadratic equation, which will look a little something like this. That's negative b plus minus square root of 5 squared minus 4 negative 4.9 30 all over 2 times negative 4.9. And so go ahead and jump to the answer, because I know what it is. The 2 times we should get are 3.04 seconds and negative 2.02 seconds. Of those 2 times, one of them makes sense and one of them doesn't. Which one which? Right. Because from our starting point of at time equals 0, time would logically only move forward as we launch the rock. So this is the number of seconds after that point the rock will be on the ground. This would represent the number of seconds in the past that the rock would have been about here. And if it was thrown from here, it would eventually end up there. But again, that's a situation that only makes sense mathematically, not logically or physically. So that's the one we throw out. Which leaves us with a time that is now usable and to plug into the x-axis. So looking at said x-axis, things are generally the same as before, except we have a different velocity and a different time. Roll. Did you add them? That's okay.
26.3.
Nice. 26.33. So, that's further than 19. Number 19, we only threw about 24.7, I think. So this is a meter and a half further. It's a good 5 feet or so. And we did this just by changing the launch angle, because it was the same launch velocity, just a different trajectory. So, in general, at any point in your life when you've thrown something, would you say that you tend to throw straight horizontally, or if you want to chuck something as far away as possible, like how usually do you throw it, and what does its trajectory look like? Okay, very good. You're on like that angle, like your body naturally throwing at that angle is your brain doing it like subconsciously trying to maximize your throw. Because angling your launch like this can get you more range than just throwing horizontally. But up to the maximum, the furthest happens at 45 degrees. And when most people throw, they sort of subconsciously end up at about that angle just because they've been experiencing this their whole lives. So you might not have done this part before, but your brain noticed. So if you want to have, at any point, if you want to throw as far as possible, chuck at 45 degrees. Any less than 45 degrees, and you're not going to have a very big hang time. So by changing the angle, we increased our hang time. Even though our X velocity got slower, the increased time still carried us further. We had more time to get where we're going. But if you launch at above 45 degrees, like if you were shooting at 60, then suddenly you have a huge hang time with a very slow forward velocity, and you're just not going to go as far. That's kind of, the logical extreme of that is if you just throw straight up. Great hang time, you're not going to go anywhere really. So, yes?
Remember the last one we did not have extra velocity. So for the beat to this one, we did 8.66.
Oh, for B, yes. So for part B, the two components are 8.66 meters per second in the x-axis and 5 in the y-axis. For the first one, the answer would have been 10 in the x and 0 in the y. How do you feel so far? Okay. Now, I realize doing this together, seeing it on the board, it might make total sense. I know that's a completely different thing to recalling it than doing it by yourself. So that's why I want us to have that extra day next Friday before the test happens. So we'll give it the week to let it sink in. Keep the basketball question to work on as practice. And on Friday, we'll have all of this graded back and we'll talk about it and everything else that will be on the test. I've never actually seen a binder that worked like that to yours.
Only that you do this, I usually break the ones that actually rings.
More flexible material. That's interesting. I just hate binders, so I never use them and my papers end up strewn about everywhere.
You still want to say it?
Not in this building. I have one at my home office, and I keep forgetting to bring it.
I mean, what kind of light side? What can you bring it? Maybe it's a missing in the building.
Yes, because this building just eats equipment. We keep buying lab supplies, I keep reorganizing the supply closet, things keep vanishing, and we keep needing to buy more.
I can work for next semester.
Yeah?
We have 3 classes.
Ooh, nice.
Physics, organic chemistry,
Well, I'm glad you only have 3, because I've heard people complain a whole lot about OChem, and especially physics at the same time. So, smart move.
The route we're supposed to take is with early entry classes. We're supposed to take both chem, physics, and statistics all of it. But I've already taken stats, so I'm not worried about that. I have it.
I cannot imagine those all at once.
Honestly, that's the hardest semester.
That sounds like it.
And then you got other classes on top of it, like religion.
Oh, yeah. Yeah, when I first started here, like the first advisor that I was given, maybe the system's different now, I was assigned an advisor who had nothing to do with the major I wanted since I wasn't declared yet. And he was a religion professor, and he just told me, I have no idea what you need for a physics degree, so let's just get your gen eds out of the way this first year. So first year was just gen eds. I bombed Spanish and art history, but got to sophomore year, I got to declare my major at that point and start taking just nothing but math and physics toward the end of my time here. And I didn't have to worry about the gen eds because I just got them out of the way that first year. So that was nice. I don't think I ever had to actually take stats here. For physics, I needed like calculus 1 through 4, and then I took some extra class to get my math minor. All I know is my students keep complaining about OChem and PChem. I think so. I only had Chem 1 and 2 here. Didn't have anything more than that. I also didn't take any bio classes at this school, so everything I hear about the bio department just goes right over my head.
It's just because I don't like biology. I also think my mom, she can't manage me. That's my mindset in class. My mom, see the point of the class, like the objective physics, understand how things work around us.
Yes.
In biology, I know things how heart beats, so when I just know, inflation.
As a kid, I probably favored biology just because we talked about animals, but getting into high school, the biology classes just became memorizing taxonomy and body parts and cell structure. And meanwhile, physics and chemistry was becoming more problem-solving oriented, which appeals to my brain. Yeah, physics is about quantifying and logically working on the system, but upper-level biology appears to just be memorizing as far as my brain is concerned.
That's what he told us, Dr. Richard here. And he warned us that first day of class, he was like, I'm warning you now. For this and other biologies, it's strictly memorizing. So you want to look at your notes every day after class. I said, yeah. Right. See you next week.
See you. Have a good week.
You too.